So here's another optimization problem. Suppose a man has a farm that is adjacent to a river. Suppose he wants to build a rectangular pen for his cows with 500 feet of fencing. If one side of the pen is the river, what is the area of the largest pen he can build? So I just made a little equation here to represent the situation. So I don't really know what the dimensions, so I call this width as x, and I add this 1 plus 1 is equals to 2x. So this use 2x of 500 feet of fencing. So the remaining amount of fencing is 500 minus 2x. You got to take away the 2x. The thing that we want to maximize here is we want to maximize the area. Well, the area of this pen generically, right? To get the area, we just take the width times the length. Would be, so area over x equals to x times 500 minus 2x. So so we want to maximize. So again, to find the maximum and minimum, we're gonna come up the derivative, find critical points, and do all this. To get the formula of this pen, what I do is to get the picture, and if I don't know things, which is this case, we certainly wouldn't just label them generically, and hopefully you just as you go for this. Before I take the derivative, I immediately I have to use product rule here. So now I've got 500x minus 2x squared here. So we want to take the derivative set equals to 0. So now here is 0. And we would also like to know where the derivative is undefined. So as we all know, the derivative, again, for this type of equation, 500 minus 4x, this is defined for all values of x. So I simply crash out the undefined. We can certainly take the derivative and set to 0 to solve 500x minus 0. We can add the 4x on both sides in here. So we just, so again, if the problem is phrased correctly, the maximum minimum have to occur at the critical point. So I move 4x here, so 500 over 4x, and we can divide it into 4. So I simply canceled out these 4 here, and I divided 500 into 4. That we will have 125 over x. So here is our critical point, 125. 125. So here's, I'm going to put 0 here, so we can we're just going to take a number or any number greater than 125 or in between 0. So I'm going to use x equals to 1. So I put the 1 in our derivative in here. So what I got now is area times 1 is equals to 500 minus 4 times 1. So what are the main thing to catch is in this case is 496, which is a positive number. We got that 496 because we got the 500 minus 4, and now we got the positive number here. So notice we can make x bigs because based on this formula, so we should be bigger. I think we could use 250 here at the x, so let the s take between 125. So I'm going to use 200, and we're just gonna take number again lesser than 125 or in between 250. So I input again the 125 here, and so I input here the 200, as you can see in here. So in the derivative, so 500 minus 4 times 200, we've got negative 300 because 4 times 200 is equal, negative 4 times 200 is equal to 800 minus 500, now we've got 300. So now we're going to use the critical point 125, and we're going to put in our derivative in here. So now the maximum area is A equals to 125. So equals to 125 times 500 minus 2 times 125. So now we're going to bring down the 125, and now we're going to multiply it by 500 times 250 because I multiplied 2 by 125, now we get 250. And here we're going to bring down again the 125, and I just subtract 500 into 250, and now we got 250. So what I did here is I multiplied 125 by 250 and getting the answer of 31,250 feet